أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Today we will be talking about ceramics material that are special type of materials widely utilized in different sort of applications. This lecture is a part of the lecture series regarding the course of nanophysics and technology having the course code of PHY445. At first we need to discuss the classification of ceramics materials. Ceramics material are mainly classified into different types that include the glasses, and glasses are used for different applications, including optical properties for the composite materials, just like reinforced composite, and for containers and household applications. Clay products are also a part of the ceramics materials and the type of ceramic material, and the whiteware we use normally at home and different places. So that includes the structural ceramic as well. We have refractories. So refractories includes the bricks for high temperature, that is specially used in furnaces, and abrasives are also a type of ceramics materials. So abrasive includes the sandpapers, the cutting and the polishings. For this such sort of application, these abrasives are used. We have cements. Cement is also a part of the ceramic, a type of ceramic material that are basically used in composites and in structural applications. Besides this traditional ceramics, we have some advanced ceramics as well, and the advanced ceramics are basically used in advanced technology, including engines and for the rotors of different engine or turbines, and it is used for the valves and bearings, and it is also widely used in sensors. So we have ceramics, and the application of ceramics includes the in some places we need material that has high resistance to at the surface. So we have die blanks that need wear resistant properties, and die surfaces is around 4 mm polycrystalline diamond, and particles that are sintered into a cemented tungsten carbide substrate, and that is made of polycrystalline diamond, which give uniform hardness in all direction to reduce the wear. So such type of die are specially used in the synthesis of the material or in the tensile force, conducting the mechanical properties of some materials, including the tensile properties and some other properties as well. The bars made from this special type of ceramics are often used for the ball milling. That is actually a synthesis process used for preparing different sort of materials. We have cutting tools. The cutting tools are also made from ceramics materials. So the tools for grinding glass, tungsten carbide ceramics, for cutting silicon wafers, and for oil drilling, such type of ceramics materials are used. Just like this is the bit that is used for oil drilling. We have blades that are used for cutting something, that is very sharp blades. We have single crystalline diamonds that are also used, and single polycrystalline diamonds are also used for such type of application. So materials manufacture single crystals or polycrystalline diamond in a metal or resin are for further use. So polycrystalline diamonds reshape by micro fracturing along cleavage planes. We have some other application of ceramics that are especially in sensors. That is actually a part of advanced ceramics that has advanced applications. So example include the zirconium dioxide ZrO2 as an oxygen sensor, and in this case there is increased diffusion rate of oxygen to produce rapid response of sensors signal to change in oxygen concentration, that is oftenly used. And we have another approach for the addition of Ca impurity to ZrO2 that change the properties, and it increases the oxygen vacancy, leading to increase in the oxygen diffusion rate. So in this sensor, basically there is voltage difference produced when oxygen ions diffuse from the external surface through the sensor to the reference gas furnace. And what happens, there is the magnitude of voltage difference in this case is proportional to the partial pressure of oxygen at external surface. So this is some of the principle behind these particular sensors that are widely used. We have refractories, and refractories are the materials to be used at high temperatures that are specially used in high temperature furnaces, just like we have silica, SiO2, alumina, L2O3 systems. So we have silica refractories. Silica refractories are silica rich, and it has small addition of alumina depress melting temperature that lead to the phase diagram. So we have, this is a phase diagram for the preparation of alumina in this particular case. So we have advanced ceramics that are basically used for automobiles, and advanced ceramics has the high efficiency because it reduces the wear. It has very high wear resistance and are stable at very high temperatures. So specifically such type of ceramics are used in the interior part of engines, because even if the engine is operating at very high temperature, the systems are the ceramic layer is stable, just like especially we are using thermal barrier coating that are heat that give heat insulation to the engine, as well as it is stable at very high temperature. If we look toward the normal metal, it becomes melt at its melting point. It is at its melting point, so leading to the damage of the interior of the engine. So normally the ceramics material for the interior of the engine is the best options. So if we look toward the advanced ceramics, there is some advantages as well as disadvantages. For advantages, we say that operate at a high temperature and high efficiencies it have when it is used in automobiles. It have low frictional losses, and it can operate without a cooling systems, and it can lower weight than current engine. If we look toward the disadvantages of this ceramic material in automobiles, then ceramic materials are brittle. I mean, if you apply force on it, so there is no elastic deformation in it. Abruptly the plaster deformation will occur, and the plaster deformation will lead to the fracture of the material. So that is a big problem with ceramic material that are actually brittles. So it is difficult to remove internal voids. Preparation of ceramics are a bit different, because if there are some voids trapped inside it, or there are some pores trapped inside it, so it is very difficult to remove the internal void out of that. So ceramic spar are difficult to form and machine, so that is another problem with ceramics material. So we have potential candidate material for this is Si3 and 4 Si silicon carbide and ZrO2 that are possibly used for the engine parts, engine block and pistons coatings and turbines. So the advanced ceramics are also used for armor. That component is outer facing plates, that is backing sheet, and the property of such material should be hard and brittle, and that can fracture high velocity projectiles, and it has backing sheets that is actually soft and ductile, and it deform and absorb remaining energy, including the aluminum synthetic fiber laminates. So ceramic fabrication is different from the normal metal or other material fabrications, because the methods followed for the fabrication of ceramics includes different steps in order to remove the voids inside that particular materials. So we have a different method for that, just like we have glass forming, we have particulate forming, and we have cementation. So brewing of glass bottles, that is actually some mold is prepared, and the sample is the sample is placed out of that, and then it is pressed with some other material, that is actually the pressing operations, and finally it is suspended pressure, and at the finishing stage it is molded again, and compressed air is finally applied to get a thin layer of ceramics to finish it, and that is used further for applications. So the pressing is actually, for pressing we use plates, cheap glass formed by application of pressure. The mold is steel. The mold that is used, that is steel with graphite lining. We have fiber drying out of that is used for that. We have sheet glass forming, that is another way to produce glass. In sheet forming in sheet forming there is continuous casting. The first the ceramic material is converted into liquid or a molten form. So sheet are formed by floating the molten glass on a pool of molten tin. So what happens? The raw material is placed in the raw material place, where it is heated to high temperature. When it achieves a high temperature, it is converted into molten state, and then it is pressurized toward other compartment, where we have heating zone at that, and there is soon after the heating zone there is a fire polishing zone, and behind the ceramic layer there is a liquid tin that is used for that, and at the same time combustion gases and control atmosphere is used for this casting processes. And then finally when it is casted, there is a cooling zone, and final annealing occurs at the annealing furnace, and finally the sample or the material is prepared, which is cutted in particular shapes for use in particular applications. We have glass structures. The structure of the glass is like silicon is connected with the oxygen, with the four oxygens. So glass is nanocrystalline, that is actually amorphous, and few silica is in CO2 to which no impurities have been added. Other common glasses contain impurity ions such as sodium, Ca, aluminum, and B. So that is so quartz is often used for that. So quartz is in crystalline form, that is SiO2. The properties of glass is that it can be shaped to a particular through a particular casting technique. So there is specific volume versus temperature curve is drawn. So we can have crystalline material for that, so that crystallize at a melting temperature Tm, and that have a broad change in its specification, and that have a broad change in specific volume at temperature T. So glasses do not crystallize and change this change in slope in specific volume curve at glass transition temperature, that is represented by Tg. The obtained glass is transparent, having no grain boundaries to scatter light. So this is the glass curve for the with in between the two parameter, that is the specific volume of that glass and the temperature. We have glass property that include the viscosity as well, that relate the shear stress and velocity gradient, and this slide describe their particular properties. We have glass viscosity versus temperature is again drawn for some particular sort of materials. This is for different silica, just like soda lime, pyrex, and 96% silica and fused silica that is often used in it. There is a particular annealing process, that is actually high temperature heat treatment of that glass, that is also called as annealing, and the annealing removes internal stresses caused by uneven cooling, and the tempering puts surface of glass put into compression and it suppresses growing of cracks from surface scratches and sequences before cooling. So here we have the sample that is hot before cooling, and then we cool the sample. There is initial cooling. So cooler, we have different region out of that, just like the surfaces. The outer surfaces are cool while the interior of the material is still hot. So we can bring this so there is a high temperature gradient in between the different surfaces. So what happened, this high temperature gradient, a high temperature difference lead to the compression and tension at different part of the ceramics materials. So that is why it is essential to remove the stresses caused by this particular sort of cooling processes. So it is the surface cracks growing in. So what happened, the cracks are expected to be created, and that because there is a temperature difference that lead to the stresses, and this stress finally lead to the cracks. We have another method of glass forming, of ceramics forming, that is actually particulate forming. And particulate forming, we have hydroplastic forming, that in this particular process we need to mill and screen constituent in desired particle size and extrude this mass out of that. So this is another process used for the preparation of ceramics materials. In this case, in the particulate forming, we also perform the casting process, that is actually called as the slip casting process. In this process, the mill or the grind that is used for this slip casting that is placed, and it is shaped in particular shape. I mean, first we need to pour slip into mold, and that is actually a solid compartment, and then absorb water into the mold to shape it. So we have green ceramics that is actually prepared after casting. This is actually the casting process that gives us green ceramics. In this particular process we get such type of green ceramic, and in this particular process we get such type of green ceramics. So this green ceramics is further heated at high temperature and it is sintered to improve its hardness. So we have hydroplasticity of, I mean, the clay that are actually the traditional ceramics are often used this method, just like we have bricks that are also used are prepared with it. And then after the casting, it is there is a drying process. I mean, the green ceramics that is prepared, that is dried, and then finally we have a firing process where it is heat treated at high temperatures. So that lead to the firing and finishing of that particular ceramics materials. So the heat treatment is performed from 900 to 1400 degrees centigrade, and that have the what is the basic idea behind the heat firing process to liquefy are the liquid glass forms from clay, and flux flows between the SiO2 particles that lowers melting temperatures. So we have pressing, powder pressing technique that is used for both clay and non-clay composites, and that is further used, and in this case we see that the porosity is reduced. Sinting is a normal process that is occurs during the firing of a piece that has been powder pressed, and that is utilized for that. Tape casting process is also used for different ceramic material that is often used for preparing thin sheet of green ceramics cast as a flexible tape, just like for Dr. Blad or some other things. The tape casting process is used. That is, we have hardening of paste and formation of rigid structure. The hardening process and Portland cement is used for that. And this is something about the ceramics material, its production and its preparation for its different sort of applications. So thank you very much for today.